Welcome to Digital Education Hub. In today's session, we are going to learn the complex number. So here in this, the basics of complex number, that is the introduction part and its graphical representation. Let's start with the session. A complex number, so it is represented by a value z which is equal to a plus I. Now this part is belonging to the complex values. Now to understand this idea, okay, so we can say that here this a part is nothing but real value and this b part is imaginary value. And what is I? So I is imaginary term. So that is the complex value. So here the value of I is root of -1. So let's first of all understand how we came across this real number, sorry, the complex numbers, and we will try to understand the idea behind that one. So here if you see this here, this representation, you have studied that natural numbers starting from 1 to n, whole numbers are there. Then the integers are covering that whole numbers also, the integers that is from -infinity to infinity. Then we have the group of rational numbers, which is, so all these integer is a subset of rational number, and here this rational number is a set of real number, which is basically denoted by this one, denoted with this one. Now, and so real number is having both rational and irrational. So when I am considering the real element, okay, real value, and I am combining that real value with this imaginary number, okay, imaginary value, then that value along with I, this becomes complex number. So you can see this representation. So here this part is called as the complex number, and generally this is denoted with z symbol. Okay, so a complex number, we can say that all that other numbers numbers are basically the subset of complex number. So it's an imaginary term which was conceptualized to solve the various situations. Now what situations we are talking about? Suppose, see, every negative number square is leading to positive value. Okay, so can I say that is there a number for which then this result is negative? To achieve such case, we came across this number that says that the result is this one. So while taking the square roots, various possibilities, while solving the equations, various equations in various areas of mechanical, electronics, computers, this idea of complex number is very useful. So we came across that method. So here you can see that with this complex number, so with this complex number, the square of this complex, sorry, the square of this imaginary term I, so since root of -1 is equal to I, therefore I square, I can say that is equal to -1, correct? So this is something which we can say that which satisfies the condition of that square of a number is negative. So we are going to take this into the consideration, and with this one we are going to expand our concept. So for a complex number z, which is represented with a plus I b, belonging to a complex value, then we can say that here a is nothing but real part of this z, b is imaginary part of z, okay, I is imaginary term which is equal to root of minus 1. So with respect to this particular concept, so here real number of z, so basically this number would be belonging to real number. So this is a part of that. This is, see, this base b is also a number. This is the imaginary value, but along with I that becomes imaginary. So that is also be going to be part. Now when I'm considering this one, so with respect to I, we have certain properties. So I equal to root equal to minus 1. So I equal to root of minus 1, sorry. Then I square will give you root of minus 1 the whole square, that is equal to minus 1. So similarly we can say that I cube is equal to minus 1 raised to 3, or I can say that I can write this I cube as I square into I. What is I square? That is minus 1 into I, and that gives you minus I. Similarly, I raised to 4 can be written as I square into I square, and I square is nothing but minus 1 into minus 1, which is going to be 1. So we can say that I raised to 4 is. Now with this concept we can say that I raised to 5, let's see, I raised to 5. So I raised to 5 can be I raised to 4 into I, which is nothing but I raised to 4 is 1. So 1 into I, which is nothing but I. So I raised to 5. So with this case I can say that I raised to n so here I raised to 4n plus 1, or we can say that instead of 1 we can say that r is equal to I raised to r. That is, after every 4n the value repeats itself, so you can see that I raised to 1 and I raised to 5. So I can say that this means that here r can be 0, 1, 2, 3. Okay, so with this case, so we can, so I raised to 5 becomes 1, so I raised to 9 also becomes 1, sorry, I. So that idea is basically, so I can say that I is equal to I raised to 5 is equal to I raised to 9, I raised to 13, like that. So it is periodic in nature. Okay, So it is having certain properties like this, and then we can expand this concept to the equality of two complex numbers. Suppose I am having one complex number as 2 plus 3i. So this is z1, or I can say that z1 is equal to a1 plus b1, that is ib1, and the next complex number is a2 plus ib2. Now these two complex numbers would be same provided their real and their imaginary terms are also same. So we can say that here z1, that is this z1, would be equal to z2 if and only if a1 is equal to a2 and b1 is equal to. So this is the case. Now our next concept to learn is the graphical representation of a complex number. How this complex number is represented graphically. So we have this complex number, you know this one. Now, so this is assuming, this is on a concept of, like we have so this is a representation in, so this is where we have x-axis and this is y. So this is, we can say that this is a imaginary axis. So here I am going to represent the imaginary terms of, and this part I can say that, so instead of x we can say that it is real of this complex number, and this is, so while drawing we can say that we have a point. So here, somewhere here we have a, so this point is a, and somewhere here we have this imaginary z. So when I take this one, so we can draw a imaginary line which is intersecting both of these, and that would give us this point. Okay, so here this point is z. Okay, so this is the graphical representation of this. Now here this angle is theta. Okay, and this becomes the r part, radius. So according to this will create the polar representation of this complex number. So the previously which we have studied, that is z equal to a plus ib, that is called as rectangular representation, and the graphical one where we are using r and theta, that would be basically creating the polar form. We will see that in the next session. So if you like this video, please like, comment and subscribe to the channel. Thank you very much.